I thank Phil Schoenberger for being here to support the webinar and actually had the idea for helping with this presentation and bringing it forward. So with that, I'm going to turn it over to Phil Schoenberger to present today's webinar with the rest of our panel.
Hey everybody. Could you talk to Warner? We're having some connection issues, so obviously the people that can hear me, I believe, are on the right site. Stay tuned for your colleagues. There'll be some that aren't able to get in. There were two separate announcements for two separate webinars, and you need to be on the one for today, March 3rd. And we'll go from there. So for those of you who are with us today, anyway, thanks for coming. It's great. People are here. That's wonderful. I wanted to talk about some things that hopefully will be of help to you as well as to us here at the lab in Lincoln to expedite you getting the data that you need. And a couple of things about this whole process. First of all, there's half a dozen of us here that are going to talk today. And Sean's already mentioned that. We wanted to hit a few things that seem to be kind of regular issues affecting a lot of people. And that was more samples rolling in. And that's a good thing. In that process, some things have become apparent to us, which is there seem to be some issues that are recurring, and we think that it'd be worth talking about today. Today we want to talk about mostly about sampling and samples. We have the fun stuff today. It's kind of the straightforward stuff. Tomorrow in round two, you're going to be talking more about forms and data entry and that kind of stuff. And so we get the fun stuff. I wanted to make the comment that when it comes to sampling, the bagging and tagging of samples and putting them in a box and getting them on the road, it takes a lot of work, but it's only the first part of that journey from the ground to having usable data on your computer. And okay, well, that's nice. There seem to be some common pitfalls and roadblocks and mostly unintended consequences that really slow the whole process down. And so we want to avoid that and to help you get your stuff as soon as possible. That's the bottom line. We have some examples of how to avoid those most common roadblocks and headaches. We're going to talk a little bit about sample sizes, a little bit about sample integrity, and a little tiny bit about documentation that needs to be done. And some of this you've heard before, some of it will be new. Some of you have done this before, but it's been a while. But we're going to have different section leaders and group speak to each. Okay, so I guess what it really comes down to is the old adage about it's GIGO, right? It's garbage in, garbage out. Or if you want to take the high road, it's good stuff in, good stuff out. When it comes to samples, a lot of things can get off the rails if we don't pay attention to details. Details matter. You need to be a little bit persnickety, a little particular on how we go through this whole process, because what may not seem to be important to you can be a major stumbling block to someone else down the line, and those details do matter, so be particular. It's the whole concept behind measure twice and cut once, and we really ought to try to avoid excessive use of cliches. And being rusty is understandable, but staying rusty isn't. And I wanted to say that there's been a bit of a sea change in management attitude about some things, and one of those is we can make house calls. There are not a lot of us here, but if you get in a problem, or if you have an inexperienced crew, or there's a particular project or that would benefit from participation by somebody from the lab, we can make a limited amount of house calls on site to help with the whole sampling process. So that's a good thing. So if you haven't done it in a while, or if you've never done it, take advantage of the opportunity to go ahead and make sure we know what we're doing here. And I still don't know what I'm doing. All right. So when we put a lot of time and energy, when you put a lot of time and energy into getting samples, getting the information collected, we got to get it right as best we can so that you get what you need. I'm going to pass it over to Ellis Benham here, and he's going to talk about some things, some details, and I think you'll find them helpful.
This is just general sampling comments here. Lead off, sample from a pit if you can. The smaller the hole, the more uncertainty you have, and the more the samples are beat up on the way to the surface, if you will, particularly clods and the like. Second thing is horizonate before you start sampling. Mark it off with nails or golf tees, whatever, and get agreement from the folks there. If you have to do rock, paper, scissors, do so, but nevertheless, get agreement of what layers you're going to sample. And the reason for this is that changing the approach halfway through one gives a lot of opportunities for numbering and identification to get messed up in one of the several places it gets recorded. Next one down is label all your bags and tags before you start sampling. It's better to have one person do that. Just get out the magic marker and attack the things. And that way it will stay more or less consistent. I've had good luck with recording the information first on the head-on field sheet, the old blue sheet, which is now a spreadsheet, and then transferring that information to the bags and the tags. Keeps things synchronized at least. The tag typically contains the series, the horizon, user PED-on ID, the depth in centimeters, and the field number. And I'll make a couple of comments on that field number. What we're trying for here is 3 separate ways to identify every sample that's pulled out of the field, a bag, a clod, whatever. And that field number is one of them. It has little meaning outside of the particular project that you're in, but it is a way of identifying things if something goes sour with the other identifiers. And the field number needs to go in the bag, the tag, in the clod box lid, on the clod bags, etc. It's a short sequential number, and it starts at 1 for the first PED-on that you sample for this batch of samples that you're going to be sending in, and it just continues to increase 1 per horizon. And if over the period of a week you sample 62 total horizons in 6 PED-ons, then the field number of the last one you sample on Friday is 62.
I want to repeat that just real quick because it's something that trips people up. It should be the leftmost column on the PED-on spreadsheet that you fill out, and it's headed by the term field number, and it is nothing more than the sequential number in the order in which you sample throughout that whole effort. So the first PED might have, starting at the A horizon, might be number 1 and goes down to the bottom of the pit. You might end up with number 8. The next pit you go to starts with number 9 and goes down to 13, or whatever it is. So you can just continue with it. And it seems like a tedious, unnecessary bit of information, but it is extremely helpful when things get confused, which they often do, to be able to backtrack and say, okay, I know that where this particular bag of material fits, or where this box sample fits.
Another suggestion is sample from the bottom up. This mostly is to avoid contamination. fill the bulk bags about 2/3 full. If you have a horizon that has a lot of rock fragments in it, you may need to take 2 or 3 bags, but leave about 1/3 of the bag for the double fold and stapling at top. And the bulk bags have a double fold, and they're stapled with about 4 staples or so. The heavy-duty ones from the staplers that we send, not the desk staples, which stab the people trying to unbag it in sample receiving. And this one is a separate topic to some extent. The thin section clods need to go in a separate box. The reason for this is in the bullet point below. You should only put a staple in the top of the thin section clods. Do not put staples in the bulk density clods. And when clods come in all mixed up in the same box, we have to hunt for staples to try to figure out which is what. And we have little metal detectors and things of that nature, but it still takes quite a bit of time, and 2 or 3 people may have to look at it to decide, yes, there really is a staple somewhere over there under the saran. Now then, I'm going to turn it over to Larry Arnold to discuss some of the sampling and shipping issues.
Thanks, Alice, for getting us off to a good start, and Phil. I'm going to give you a perspective from the sample processing receiving area of the laboratory, because once they're boxed up and sent into the laboratory, we're the first ones to see them, and so we'll start logging them in for sample submission. And I want to go over sample volume. Just like Ellis said, we need a adequate amount of volume, and there's things that will compromise that, such as the amount of frags that are in the sample that you're taking, how much water is in the sample, whether it's organic. And so, you know, if we have 50% frags by volume in a sample, then maybe we need to think about having 2 bags instead of 1, because when we process the samples, which is the next step, we'll fill containers, and if we can't fully give enough sample for what the technicians need in the lab, then we have to decide what the priority order is on the analysis. So wet samples, they'll take up quite a bit of space. The liquid does, especially if it's organic, and so it could be a significant amount of the volume. So we'd recommend that you dry out the samples, open up the bags before you prepare them to be shipped, and let them dry out and get them to a fair, not a dry, but at least the excess water, pour it out if it doesn't compromise the samples. And just like Ellis said, 2/3 full is adequate for a standard mineral sample soil. That we should have enough for that. I mean, for some full characterization samples, we need at least 2,000 grams of mineral soil. Probably the average is about 1,000 grams. So if we can get the equivalent to that when it comes to the mineral soil, we should be adequate. As far as clod boxes, clod boxes, we want to make sure that they're adequately labeled, just like the bulk sample bags are, both on the inside and the outside of the clod boxes. As you know, they're specific boxes that we use for clods, and they do have numbers on them. And we want to make sure that everything's labeled according to where the cell number is. And if you fold the box down, close it, the number should match up on the underside of the box and on the lid. We want, if we're sampling, if we're filling the clod box, we want to put those clods, typically 3 clods you know, for a pet or for a horizon, you know, we want to put them in a logical order. If you're sampling for every layer, make sure that they go. We typically do it from the closest to the lid, go 3 clods, and then the next pet-on would be just to the right of that, and then we'd have to move down one row and start the next one, 3 clods, and so those cells you can put 24 clods in there, and so that would be eight horizons. And so that's the way we'd like to have it, because that if we start putting them in a different order, then it tends to cause some confusion when we're logging in the samples and assigning sample numbers and submitting or compiling the information about all the samples that are coming in. So for shipping purposes, we want to make sure on clod boxes that we fill, if we don't completely fill all 24 cells in that clod box, we want to fill that with packing material, because that, if we don't, it compromises the samples during the big potential to compromise the samples during the shipping of the samples. So filling the empty cells with something before you ship them, if you don't fill them up totally, is very, very important. And then also when we're shipping the clods, we provide specific clod boxes or clod trunks for 6 clod boxes, and we want to make sure that 6 clod boxes are being shipped regardless of whether they're filled up or not. And if they're completely empty, all you got to do is put the inserts in to make them a little bit more rigid, but put all the filled boxes in the bottom of the clod trunk, and you can put the empty ones up on the second row. So send descriptions with the bulk samples. We're going to be talking about some other paperwork, sample submission sheets tomorrow that will be required, but make sure we have the field descriptions that you print off from NRCS that you put in NRCS before you ship them. So we'll go to the next slide here. The NSSC does provide appropriate supplies and equipment, and we provide tried and tested supplies and equipment, just so you know, because we've been doing it for a long time, and so that's one of the reasons why sometimes we have compromised samples, is because maybe those weren't used. So we're more than happy to provide what you need. We also will provide the required shipping boxes and liners that are needed for returning the samples back to us, and that includes for clods and for bulk samples. And so that will automatically come whenever you request sampling supplies from us. Consumables such as bags, tags, saran, and those type of things, don't be afraid to ask for more than what you need, because we have plenty of those on hand, and it's not an issue at all to send you enough for the season or even a couple seasons. We've got a storage area that's full of those because we have to order them in large quantities. But when it comes to the hard equipment such as the trunks and the sieves and the sampling pans and stuff like that, we'd like to have those come back. That way other customers can use it. The sample submission protocol for the KSSL is a document that's on the soils website that tells us gives us the specific step-by-step directions for documentation, labeling, packaging, and shipping all soils coming into the KSSL. So please read that and become familiar with it before you send or start sampling, because that'll keep us all on the same wavelength, especially when it comes, I mean, it's practical information, but it's also required protocols for APHIS. We'll go to the next slide there. Thank you. Now, right here we have an example of some paperwork that came in with the samples, and I would probably guess that these were just thrown in with the sample bags that were in the box. And this was, if we follow the proper procedures and the protocol that I identified earlier on the soils website, this should never be an issue. But if we put the samples in this particular paperwork in folders, and then put it on top of the secondary bag, which is a shipping box, we typically put a pet-ons worth of samples, or we can put more in a secondary bag. Throw it on top of that secondary bag. Everything's stapled shut. The primary sample bags are stapled shut. The secondary bag is stapled shut. And if we dry the samples out so there's no moisture leaking, we should never have an issue like that, because everything should be clean. And if you put it in a folder or a manila envelope, that would be great too. But we'll talk about that particular paperwork, or the required paperwork, tomorrow.
I want to add a comment real quick to interrupt. Most of us here have been out and have been in the field, and we understand fully what field conditions are like. You do the best you can with the circumstances you're dealt. And sometimes stuff happens in the field, and that's just the way it is. Things get muddy, things get dirty, things get torn, whatever. But when you get back to the office, before you put things in a box to ship them, that's the time to get it sorted out, because you have a far better chance of figuring out which samples are which. And if the paperwork needs to be redone, then you got to just redo it. Because if that doesn't happen at your end, when it gets here, people make the best effort they can, but everything stops. If that information can't be figured out, everything is on hold until we can get it sorted out. So it's far quicker and smarter and efficient if you handle it.
Okay, thanks, Phil. When we get the samples in the lab to log them in, there's three things that we want to match on there, and that's the paperwork that we get in. We want the tag on the bulk sample and the writing that's on the clod box to agree with what's on the paperwork, and then we also want the bulk label to all agree. Because if we don't get all that to agree, then we don't know for sure which one is correct, and then we have to stop, and then we have to contact people that it sent the sample submitters out in the field and try to get it all straightened out. So that may just delay your project if we don't have all that information. And other projects, we constantly have other projects coming in all the time, and you'll lose your line in the pecking order there until we get that all straightened out. So, and here's an example. This picture is an example of just a tag that's been labeled properly. The bag has been labeled. You want to do it on the lower half or lower third of the bag or lower half of the bag, the labeling. And then it also shows a stapler that we would provide you. That's heavy-duty stapler, and that will prevent issues with some of our technicians reaching into boxes and bags and with desk tape staplers and poking their hands. So I just want to point out that picture real quick of what a bulk sample bag should look like.
One last comment on this image. There's the bottom statement says, lay all the bags out. The best thing you can do when you get stuff from the field back to your field office is to literally set them out in groups. Pet-on 1 is over here on this side. Pet-on 2 is over on that side. And you can put the bags in order and make sure at that time that you have all the layers that you want, that they're all labeled, that they all agrees, and then the paperwork can go with it. If you go through that step in your field office, it will eliminate about 95% or 99% of the problems that we have with these issues we're talking about.
Especially if you have multiple people in the field doing this, and that can be confusing.
Yeah, if you have different teams, it'll show up when you lay them out in your office, because then you can really see, oh shoot, we're missing something here, or these two things are labeled the same, we got to sort something out, we got to change something.
The reason we have duplication on the tag and the bag is sometimes if we ship samples together inside the shipping box, the samples might rub together, and lots of times in the past we've had the permanent markings rub off because of bags rubbing against each other, and also with the tag wadded up if it was wet or something like that. So we just have, that's why we require you to write it down 2 times, along with all the paperwork too. And then here's just an example of a big old pile of baggies as is listed up there, and this is not what we want, and this is not what it's not been labeled correctly. It's not in the correct bags, and it just lots of issues that can happen with samples that are like that, and there's no tag on them. You know.
Yeah, you can tell that there's numbers on these bags. Whoever did this, put this stuff together, clearly had an idea of what they wanted, and they had some numbering system that made sense to them. But to us, it means nothing. And so you've got to have the adequate documentation and labeling. Otherwise, we don't know what you've got, and you do run the risk of getting nothing out of the efforts in the field, because if we can't figure it out, it's not going to get processed.
There's probably, I don't know, 30 or 40 bags there, and we don't know if that's horizon layers within a ped-on, and we have to sort it out. And one piece of advice is to try to pack in an organized manner that makes sense as far as the layers and stuff like that. And so I'm not sure how these were shipped, but that's just an example of something that we have that we've gotten through the years. And we've seen it all. And here's an example of shipping problems. Not using our shipping boxes, not drying out the sample before it came in. And see, this specific box of samples, we weren't able to log them all in. In fact, I know in this shipment of samples, there was about 15 or 16 boxes that were shipped. These are not our boxes, just so you know. We would send much heavier boxes, and we would have heavier duty secondary bags, and so the problem is the moisture all leaked out of the bags while they were being shipped. Several bags leaked soil solution out. UPS, which is our shipping people, they actually they threw away some samples. We're missing samples on this project, and so because they come from such a remote area, they probably will not be resampled, and so you'll probably not be able to get the data on those particular layers that were lost, and just and down on the lower left-hand side it lists, it's the wet samples that we have issues like that, and that's why we need to dry them out before they come in and pour off the solution. And I think that's all I have. Let me see one more slide. Yep. Now we'll have Patty Jones, who's the lead tech in the chemistry, and she's going to give her perspective.
Yes, this is Patty, and I just want to briefly say that we need a minimum of 1 kilogram soil, especially if you want the saturated paste analysis. That analysis requires about 200 to 300 grams of the processed soil. If you have less than a kilogram, please let us know in order which analysis that you really want. The samples flow through the laboratory, and we do some of the initial tests like pH, predict on those so that we can know what tests we need to do next on them, and sometimes you might not want the analysis that we picked to do. So just let us know. And I also want to say that for the New Zealand phosphorus retention test, it's very difficult for us to do that in chemistry because of the soil to solution ratio. So probably not request New Zealand on those.
I want to add one closing comment on the small sample size business. Oftentimes
if you're working from a pit or something where you have lots of access, getting a large bag of soil is not too terribly challenging. If you're using a push probe or some other type of sampling protocol, you know, it's common that you may not have enough sample. Recognizing up front that you've got to get us as much sample as you can, maybe you need to punch 2 holes side by side or in proximity. There are different strategies that people can use to try to get enough material so that when you have samples run, that there's enough material physically here that they can be run as you desire them. It's also true that we oftentimes get people will send in a little bag of sample, and they start out with saying, well, I only want to know pH. And that's fine. But invariably, they get the data back, limited as it is, and they'll say, hey, you know what I really need to know is I need to know the texture. And while you're at it, I could also use the da-da-da. Well, the sample's gone. So back to what Patty said, if you physically, literally cannot get much sample, then make sure you prioritize what it is you want, because they'll run analysis until they run out of sample. That's the best you can do. Who's up? All right. A lot of this stuff just comes down to the old notion of, you know, think things through twice. You know, you can choose to go down a road, how much sample you submit, how many corners you're going to cut in writing down information, how incomplete things are. And you can do those things, but are you sure you really want to? Because oftentimes shortcuts or inadequate sample material will end up not getting you what you want in the long run. So think through the situation as best you can, and common sense is your friend.
This is a few other comments on analytical requests themselves. We're going to deal with that in more depth tomorrow. Field moist water content. It seems to be popular. There's a question as to what it represents, though. The bags are not always moisture tight, which say evaporation occurs over time. They may sit around here a while before we do an analysis on it. At best, it is some value equal to or less than the water content when you sampled. And much of the time, that probably is not of great value. Another comment is on PSDA, not for O horizons. The next slide will deal with that a bit. Moist PSDA. It's generally not needed. There are a few types of soil material that irreversibly change on drying. The general assumption is that they never dry in nature and haven't for a very long time during their development. So when they do dry, they don't re-wet well. They may harden, that kind of thing. For those, we honestly need moist PSDA. But any soil that ever dries out, there's little advantage to running moist PSDA. In fact, it's probably a disadvantage because we have more trouble getting a weight. We have to run 2 samples through, one to get a weight and one to actually run. We make an assumption that the 2 are the same, but we're working on moist sample, which is more difficult to get a uniform sample than the dried ones. So the results are generally less precise, I think, than the standard dry one. If you don't need it, don't ask for it. It's a lot of trouble. Grain counts, shouldn't be running those things on O horizons. The grains that are counted for optical mineralogy are saved from the PSDA analysis, so we're not going to have PSDA on O typically, and you shouldn't require grain counts either. Now, this is a comment, or this is one that was sent through, actually, a request for PSDA on an O horizon. As you can see, we started out with 10 grams of material. after about, what, 2.5 weeks on the hot plate with a lot of peroxide consumed, we wound up with less than 0.5 gram of material left, mineral. And we probably got representative numbers on that 0.5 gram, or 0.4 of a gram actually. But the larger question is, what difference does it make? The interpretations and the properties of that horizon are controlled by the organic, and the mineral size distribution, grain distribution, is generally of minimal importance. I know that NRCS has a place for it to be entered, but it's of questionable value. Now, a couple of comments on coarse fragments. You have the option of sieving in the field. Typically, you need 300 to 400 pounds of material sieved to get an ASTM recognized statistically valid value for 75, 76 millimeter rock fragments. But if you do that, we need both the less than 20 number and the 20 to 75 number. There have been occasions where folks have known correctly that the only number that goes into the lab data from the field sieving is 20 to 75. So that was the only number they sent us. The unfortunate side effect, though, is that we have to have both of them to calculate a percentage. So with one single weight, we have nothing we can work with. Now, the next one deals with the volume estimates. This has to add up to 100% by volume eventually. And if something comes into me, which happens occasionally, that has 115% by volume coarse fragments, I'm at somewhat of a loss of what to do with the fine earth. So I guess the take home there is check that before you send it in and make sure that it makes sense. And the last one is sort of a side effect from NRCS capabilities. You can enter whatever you want pretty much as the upper and lower class boundaries for coarse fragments in NRCS. LIMS only recognizes the standard engineering classes. So there's little that I can do with classes that are a la carte, if you will, on their bounds that are not standard classes. What I actually do with those is add them all up and throw them into a class that's greater than 2. That will handle the dilution effect in calculations. It just doesn't tell you much about the coarse fragment size distribution. Bulk density is quite important. We're seeing more and more projects come in that don't have bulk density samples. Anytime that the data out of the KSSL lab is used to calculate something on an aerial basis, per square meter, per hectare, whatever, bulk density has to go in it because we're reporting weight basis and it has to be converted to volume. So if you don't send in any samples to get a bulk density from here, you're going to be using some kind of a made-up number. So we strongly encourage sending in samples for measurement of bulk density. And there is a YouTube video on bulk density sampling that is listed here at this link. And for bulk density samples, the best that we have still is clods. In RACA, we were using compliant cavity and scoops, which is another form of it. The cores, they're more variable, and it puts more of a burden on you in the field to make sure that you have the volume right. Small volume differences are important in these methods. And when they come to us, we have clods, cores, and compliant cavity. But cores makes the assumption that the core ring is left on the sample when you send it to us. So if you use a core ring to take bulk density samples and then push the soil out of the ring into a bag, it is then compliant cavity. And for compliant cavity, any of those methods, be it frame, the core rings, the scoops, the cans, all of those things, we must have a good volume measurement, and you have to make it. We can't. We can get by with length and diameter, or length and width and height, or just volume in cubic centimeters, but you have to send us something that's a good one. And changing the volume on those rack-a scoops by 4 cc's, in other words, some holes left in it somewhere or over one corner that wasn't filled, makes a noticeable difference in the bulk density. And if we don't have those volumes, all we can do is take a couple of weights and toss the data aside until you send it in. And so that is something that we can't get by. In other words, we can't compensate. You have to give us a good volume out there. Now, a couple of other points. If you do the clods, you're getting bulk density at constant tension, third bar tension. All of the other methods are giving you bulk density at whatever the water tension was at the time that you sampled. And that varies some, obviously. And also, the structure is intact for the clods. Now, Adrian is going to be talking about these next ones. She's the one who handles the clods, and this is some images from her Hall of Shame on clods that didn't work so well.
This is Adrian. These are some clods that I've received in the lab. The top clod up there that you see, it has a nice mass to it, but you see that it has a lot of crumbles. When this crumbling happens in the clod, and when you go to dip it in saran in the field, that saran ends up going into all those little cracks and little crumbles. And actually what it makes is several really, really small clods that we can't get any bulk density information from. The clod that you see to the right of that clod is too small. What we're looking for is something more fist size. If you have any questions, if it fits in the cell perfectly, you've got the right size. So, and the clod on the bottom, this clod is too thin. What happened when we do bulk density, we like to see a lot of mass for surface so it can sit on that table and absorb plenty of water. And if you get them too thin, then that water has trouble reaching. It takes longer to reach all the way to the surface, and we also have problems. They may tip over throughout the analysis, and they don't get good contact with that ceramic plate when we do bulk density. Okay, here you see two clods. The clod on the right, that looks like a good clod. Everything's intact. It doesn't have any of the crumbles. It doesn't have any peaked edges, and we like to see them roundish with no pointy edges. And of course, fifth size or that cell size that you see on the clod box, those are perfect sizes. We need good mass for good bulk density, quality bulk density data. And the little clod that you see that says no there, that looks about like the tip of somebody's finger, that clod will not produce any usable right data for us. There's just not enough soil there. it's probably mostly saran compared to the size. And then you see some clods in a shipping box, and this kind of alludes back to what Larry was speaking about earlier, that the clods need to be the size of those cells. And you can see several of these clods in this project, the ones with the black X's, they don't even touch the edges of those cell sizes, so they're too small to do analysis on. You're not going to get very good bulk density data out of those. But if you see the clods down in the lower cells that touch the walls, and they're not going to jiggle around during transportation. And then also, if you can, go to the next one. Here's after it's been shipped. You can see that sometimes that shipping process is a little rough on these boxes. If the cells aren't filled with some stabilizers, then you'll lose some of that structure in the lower part of the boxes, and they'll crumble, and then those clods will shift around and most likely break the clods, and the contents will spill out, and then those clods are useless. We have to toss them. We can't use them.
Or they're smashed and deformed, and so the bulk density won't be right on those either.
Right. What Mike said was that we can get some compaction too on some of those that bump into each other or smash, and then your bulk density results aren't representative.
So again, this is a classic example of what happens, if you go through all the trouble and bother to get a sample in the field and go through all that pain and anguish, and then in the shipping they get beat to a pulp, and it was wasted time and effort.
Here's just another picture that represents that good size quality. You can see especially this clod down on the lower right hand corner. It fills up that cell nicely, which makes sure that there's not going to be any rattling around of that clod to break it up in that lower cell. And then if you just need paper to stuff in there, I've seen foam.
Wadded up newspaper?
Yeah, wadded up newspaper usually.
Okay. These are materials that we have some problems with in the clods. Start out with sands. It's not all that difficult to get clods from materials, if they're moist, to get clods from materials that are sandy enough that we'll never be able to analyze them here. I've done that before. One time I was rather proud of myself for getting a large number of clods from some sands in Florida, and I think in the end 2 out of the project actually were analyzed. So if you have a texture that is coarser than a sandy loam, even if you can get a clod out of it, don't. Use one of the compliant cavities methods, a can or something of that nature. What happens here is the saran is not perfectly sealed. You get gradual drying when they sit around. And a side is sliced off of the clod so it can be put on the equilibration table. And a diamond blade is used in a tile saw, basically. The blade is vertical, so if you are holding a very sandy clod and making a vertical slice through it, the blade vibrates a little bit also. Typically, the sand will have dried a little bit, and what was really nice in the field just all runs out of the inside of the saran shell. And so we can't analyze anything. The sample's gone. If you have strong structure, something slicking sides or something like that, they can crumble. And if you dip them in saran when they have cracks that are open between them, Saran will run in there, and that will isolate that little chunk of soil from that PED piece from the rest of the clod, and there will be no water exchange, so we can get values. They're just not good values. Heavy clay, again, it needs to be somewhat moist to sample. Coarse fragments, look for pockets between them that are big enough to make a clod. This is a difficult material. That's about your only chance. If you have a lot of roots, look for a clear area is the statement here. Sometimes that's not possible. The next best thing is to get a very sharp knife and cut those things. And the very sharp knife won't be one that we send, unfortunately. Saturated materials down at the bottom there, again, you may not be able to sample them, but
the best you can do is come back when it's not saturated. That's not always possible, but it does have a lot to do with the sampling strategy that you set up in the first go. If you know you got problem soils and it's critical that you get data from them, don't sample them at a time of year when or field conditions when they're not going to give you the samples you need. It's easy to say, and I know it's hard to do logistically, but in the end, that's really the bottom line. It doesn't pay to go out there and go through all that effort and end up with nothing for your work. So that's it. That's all we got. We put you through enough pain for one day. If you have any questions, fire them up. We're here to help. We'll do the best we can. We will help train either from a distance or perhaps on a limited basis we can come out and help people. There are a lot of things that come up. There's nothing that makes people crazier at this end and frustrated is when you've gone. We recognize that this is a lot of work to get the samples in the door, but if they don't come in a usable fashion, we can't help you. And so help us help you. And if something isn't working, if you're having issues, get a hold of us. Don't get mad. Get a hold of us. We'll see what we can do to change the protocols and figure out ways to make things work better.
All right, let's open it up for questions. And again, to ask a question, you can put that in the Q&A pod on your screen, and we'll work down the list. So the first one up from the Salem Soil Survey Office, is there a diagram available that shows the preferred order of packing for clods?
We can get one to you. We can get one out there. In fact, we could just take a picture of one, and I might have a picture available that we can send out to you.
And I don't know if that relates to the labeling of it or, how those are labeled.
We do have images of how to sequence the clods into the clod boxes by row, and that shows how you go from left to right, from the top of the box to the bottom. And if that's what your question is, yes, we can provide you with some information. It would be helpful if you could send a follow-up email to the lab, to Ellis Benham. We'll get it to the right people, and we'll go from there.
Send it to who you know at the center, and
Right.
we'll get it where it needs to go.
The sample submission document that's on the soils website has lots of pictures on it, and there very well may be a picture on there.
Yeah.
Yeah.
Another question about labeling the clod boxes. Anything you want to say to reiterate how that's to be done?
For the clod boxes on the outside, I typically put the user PED-on IDs that are contained therein. You can put more than one PED-on, obviously, in a box. And on the lid inside, what's your preference, Larry?
At the minimum, the user PED-on ID with the layer number. I mean, I think that's, as long as we have good paperwork, that, and if you can include the depths and the horizon, but there, I know that get kind of, there's a limited amount of space there, but.
It is limited. On the clod bags themselves, at a minimum, that field number. That will be enough normally to identify the bag. And that's on each bag if you have 3.
Okay, the Powell office has a question on the field number. Is it based on the horizon or the PED-on number?
It's purely horizon-based. You start with field number 1, the first horizon, the top horizon you sample in the first PED-on, and it continually increments by 1 until you run out of horizons on the last PED-on that you sample.
And there's just kind of a confirmation of the standard user PED-on ID that we'd like to see. Does anybody want to go over how that goes?
We'll actually cover that tomorrow. On the spreadsheet, the PED-on spreadsheet that should come in, there is a help block that lists the content that's needed for that user PED-on ID. I think the field book also has the same number.
For quick and dirty, if you go the site ID number that's in the field book for describing and sampling soils, there is a full example that's kind of mapped out there that will help you. So it's S 2016 ID for Idaho or whatever that sequence number is. There's details there that will help you.
And we'll go over it tomorrow.
Right.
And if you watch the bulk density video that we put on YouTube, there's some good examples and explanation of that format there as well. And I'd really encourage people to take advantage of reviewing that video before you go out and do your sample collection this year, just kind of a refresher on, you know, what is the right size clod, some safety aspects of working with this, and why is, so you can explain to somebody else maybe on your staff, why is it best to have a clod sample as compared to a compliant cavity sample, and what are the reasons for that? And that'll maybe give you the impetus to do the best you can to get the best quality samples you can collect.
I'd like to reiterate something both Adrian and Ellis touched on as far as the clod size. Because the clod would need to be saturated on our tension tables, we generally cut off about 20% of the clod. So that's why you want one to fill that cell, because 20% of it's going to be cut off right off the top in order to saturate that.
All right, well, I don't see any more questions online. I want to thank everyone for their efforts to present this material today, the whole panel that we had. This is the first of two-part webinar. Tomorrow's webinar will be on sample submission, so be sure to tune into that. This webinar and tomorrow's webinar have been recorded or will be recorded, and we'll put those on our YouTube channel. This concludes our webinar.